guys! Welcome back to my Let's Code series. Today I'm going to do the first bit of refactoring and try to render a sprite sheet to the screen. Before creating the sprite sheet, I'm going to copy and paste this code to a new function that is going to initialize the game. When the promise for processing the UI is fulfilled, I'll call the init function. This needs another parenthesis, of course. Let's create a little more room for the function. The init function is going to do roughly the same as this, so I'll move it over. There. Since I'm not needing the red circle anymore, I'll just delete it. I've already placed an image to use in the image folder of the project. I just need to include it in the project, so it's included in the package. To use the image in a sprite sheet, I need to load it first. I'll create a new image object and set its source to the image. Next, I create a variable for the sprite sheet and instantiate a new CreateJS sprite sheet. I'll pass this an object with a bitmap. Because you could use multiple images in a sprite sheet, it expects an array. I'll just give it only one bitmap. To see if it works, I create a new sprite to render to the screen. It uses a sprite sheet. Now if I remember correctly, I have to go to the first frame without playing. You can define sprite animations using the same object. But I don't need that for now, so I just set it to frame 0. To get it to render, I'll add it to the stage. And let's try it. Okay, that's not good. Out of stack space. Guess I didn't have to go to the first frame. Let's try without. Still out of stack. Oh wait, I have to tell it what the frames are. Let's see. It was something like I want a frame from the top left of the image with a width and height of 768. Oh. Yes. An array inside an array. Let's use the first image and close the brackets. Let's go to the first frame again. Yeah, and I thought this would be the easy part. The next step would be dividing the image into 49 different sprites to create a 7x7 grid. Instead of using only one frame, I have to add 49. Because these are very regular, I use a couple of for loops to do this. First, let's calculate the height of every sprite, which will be the width too, because they're squares. I don't need the decimals, so I use the floor function. I know the image is 768 pixels height and divide that by 7. all frames need to go into an array. Let's loop over the rows 7 times. And over the columns 7 times 2. Push a new array into the frames array with I times the height, j times the height, the width of the sprite and the height, and a 0 for the first image in the sprite sheet. The old configuration can be replaced by the new collection of frames. Let's see if it runs. Yes. Now, as you can see, there's only one sprite rendered, because I haven't changed the render code to loop over the sprites yet. Only the first sprite is added to the stage and rendered. I'm going to create an array of sprite instances. These instances can be positioned and rotated. Let's loop over all 49 of them. 49. I think I can reuse the creation of sprites and the go to and stop function, because this has to be done for every frame. Well, I'm not going to set it to be the first frame all the time, but I create a sequence of all frames. To be able to render it, I add it to the collection of instances. I set the x position of the sprite to be the float I divided by 7 times 110. This will position them next to each other, leaving a little space between them. The y position is a little different. For that, I take the modulus 7 of I times 100. Now I'm going to loop over the instances and add them to the stage. 49. Let's move that over here and change it so it adds the instances. And run. As you can see, the whole image is rendered now, although I expected some spacing between the rows. There. That should be 110. That's what I was going for. This is what the end result of the puzzle should look like. The initial state will have all pieces rotated at 90 degrees. To make things easy, the sprites have a rotation property. Set that to 90 and run again. This is starting to look like a puzzle. The player will be able to click or tap the pieces, which will rotate back to their original position, or to the 90-degree rotation if they are straight. But the pieces above, below, left and right will turn also. In the next video I'm going to add some user interaction and have the pieces rotate. Thank you for watching. See you next time.